Alrighty, hello everyone and welcome. So, I have recorded this lesson about 6 times now, so if I forget anything or something goes strange, do just let me know. This lesson has continued to break everything, including my spirit, but here we are, once more, give it another shot. So recurrence relations for compound interest, that's what we're going to be looking at today. So, two things. I first just want to do a quick recap. Let's have a look at, once again, how do we just use a recurrence relation? What is a recurrence relation? And once we've got a good grasp of that, then we're going to go back and have a look at how does it apply for compound interest. So let's start somewhere where we're probably feeling pretty okay. So let me just write up a sequence, okay? 6, 12, 24, 48. What's the next number in that sequence? So just have a think about it. What would it be? Well, calculus is a bit hard, but the pattern's quite easy to figure out. To get from 6 to 12, what have we done? Well, we could have either added 6 or we could have doubled it. We've got to look at the next pair to see if that works. So between 12 and 24, what's happened? Well, I've either added 12, which doesn't work with the added 6, which means, but it does work with the other, with times by 2. So to get from each of these terms to the next one, I've just times by 2. Now, so what does that mean? Well, it means that there's got to be an easier way of writing this. Rather than writing out every single one and writing times 2 times 2 times 2, there's got to be an easier way of doing this. So we invented recurrence relation formulas. What does that mean? Well, it looks something like this. an plus 1 is equal to 2an. And in this case, a0 equaled 6. Okay? So what does that mean? It means that the next term is equal to 2 times the previous term, right? So the next term in the sequence is double the previous one, alrighty? And that's how we would write it in recurrence relation. And this is a recurrence relation because it links the next term with the previous term. And that's how we define a recurrence relation. And this is a geometric. Why? Because the common fact between each of them is a common ratio. We're multiplying by the same thing. Okay. So that's a quick recap of what a recurrence relation is. So I'm going to do another example just really quick. Let's go an plus 1 is equal to 6. Okay, so I'm going to just quickly work this one out. All right. So the next term is equal to the previous term times 6. 6 times the previous term. And my first term is 5. A0 equals 5. So what's my next one? Well, 5 times 6, 30. 30 times 6, a little bit harder. 180. Times that by 6, 1080. 6,480. What did I do? Times by 6 each time to get the next one. Alright, so that's the one I've had a go at. Have a go at this one. Let's have a quick go at that one. Alrighty, so hopefully pause the video if you needed a bit more time, but let's have a go through. So 5 is my starting number once again. This time I'm not timesing by 6 though, I'm timesing by 4. So that means I'm going to get 20, 80, 320. And I'll do one more term just to practice my mental arithmetic. No, I'm going to use the calculator times 4, 1280. Alrighty, so that's a quick recap of what it looks like to have a normal, standard, geometric sequence with a recurrence relation. That's our basis. Now I want to take that and I want to use that to help us understand how do we grow compound interest. Compound interest grows very similarly to a geometric sequence. It grows by multiplication. What does that mean? Well, it means that I need to times by something to get the next one. So it's not by a number. It's not like you get twice the amount of money you put in after it takes longer. So what does that mean? It means we're going to be looking at percentages. Percentage is just a nice way of representing a number that's not quite as large as other numbers that we might be dealing with. So imagine I have an account that has $6,000 in it, okay? And I get given an interest rate of 4% per annum. Alright? $6,000, and I'm going to be investing in it at 4% per annum. Alrighty, well, how much would it be valued in 1 year's time? How could I work out the next one? Well, 4% of 6,000, that's going to get me what? 600, 60, $180. And then on top of that, so it'd be 6,180. Well, that's a bit cumbersome to work out. And then to work out the next one, I'm going to have to do all of that calculation all over again because compound interest continues to repeat. So what does it actually look like? I'll show you. To create a recurrence relation, I take my basic formula. an plus 1 equals r an. Okay? Now, I need to work out this r. n plus 1, an, we've just gone through what those are, the next term and the previous term. This r is the important part. So r is just going to be equal to 1 plus the interest rate. Or you can think of it just as whatever the interest rate is for the timing period. In this case, we're just going to do a yearly compound. 1 plus 4%. Can't add a percentage to 1, otherwise I get 5%, which doesn't seem quite right. So it's going to be 1 plus 0.05 or 1.05. Okay? So that's what my r is. My r is 1.05. You can also think of it as 100% plus 4%. Where did I get a 5 from? 4. 4. Alrighty, so now I've got myself these little things, right? I've got my r value and I've got a formula. I just need to substitute in to my formula. So an plus 1 equals 1.04 an. And I'm done. Nearly. I'm just going to tell what the starting term is. A naught equals 6,000. Alrighty, so I want you to generate one of these for yourself. The recurrence relation. So this is the goal, is to get something that looks like that. Here's your question. Alrighty, so hopefully you pause the video, had a go. Otherwise, give yourself a bit more time. So let's go through. So my formula is always the same. an plus 1 equals r an. Alrighty, that's easy enough. Now I've got to work out that r value. Well, it's going to be 1 plus whatever I was. 1 plus 6%. Convert the percentage into a decimal. And now I've got my ratio, my r value. So substituting into my original formula, an plus 1 equals 1.06 AN. Starting with A0 equal to 4,000. Alrighty. So that is a real simple example. Now what I want to do is to just take this and add a little bit of context around it. So, what does that mean? It means I want to have a worded question. So, let's have a think about it. So, Martin invests $45,000 at 6% per annum. Construct a recurrence relation for this compound investment. Alrighty, so it's a simple worded question. I will go through. So let's decode it, turn it back into something that we know how to deal with. 4,500. That's going to be my A0. And 6%, that's going to be my I. And it's per annum, which is important because it means we're doing things yearly. And this is going to come up in just a moment. Alrighty, so let's work out my R. R is equal to 1 plus I, which is equal to 1 plus 6%. Got my R, 1.06, put it into the formula. Done. Alrighty, so there's my question. This one is your one. Have a go at that one. Alrighty, so hopefully you've had a go at that one in your book. Now we'll go through the answer. So A0 equals 6,500. I equals 5% per annum. R is equal to 1 plus I. And my final answer okay, so we've now created a recurrence equation, but this doesn't actually tell us anything about the value of the account, right? All I know is that it starts at 4,500, and to get the next one, I'm multiplying by 1.06. But what is the next one? Well, let's write it like a sequence. I'm going to write it a little bit differently to a sequence, though. I'm going to do it in a table. So let's have a think about it. I'm going to put year and amount. N is my year, and my amount is written as A of N. Right? So my N, well, it's going to start at 0, 1, and I'll just do the first 2 years. So what's the value of A0? Well, it's 4,500. How am I going to figure out the next one? Well, my rule tells me multiply by 1.06. So that's what I'm going to do. Multiply by 1.06. So 4,500 times 1.06 gives me 4,770. 4,770. Right? And so that tells me, after a year, how much is in the account? $4,770. What about after another year? Well, once again, I'm going to take my previous answer and multiply it by 1.06. And I get 5,056.2. So in 2 years, after 2 years, $5,000 will be saved up. Alrighty, so that's an example I've done with my situation. Now I want you to construct a table for your situation. Going to be similar, but not identical. Pause the video, have a go. Alrighty, so my end value is 0, 1, 2. Now I'm going to put in my starting value, in this case 65,000. So 6,500. And similarly, I'm going to be multiplying by my common ratio. This R value, 1.05. And now it's calculator business from here on. So the next one should have been 6,825, and then repeating that again should give us 7166.25. So at the end of 2 years, the value would be 61,666.25. Alrighty, so that's a quick introduction to recurrence relations. Alrighty, have a go at the questions. If you have any trouble, please let me know.